Yeah, it's just the maintenance data collection computer. But once again, as I said, it's that hub. It's where all the information is going to go through and be redistributed. And we all know about the 737 Max problems, and that's from everything that I understand and what I've read in my personal knowledge. It's OFP software not accounting for the new CG. They did physical structures changes and they didn't update the software. So what if you were able to actually update the software and somebody could send a regress into that system? But if it's okay, we can all panic, but there's no need to. It'll be all right. First off, you have to gain physical access to these devices, and we all know how hard it is to get on a flight line when you're not allowed there. There's future fixes in play, and there's some things that we are actually using. For instance, encryption is being used on the Link 16 combat network. And as was brought up by Ken, there's a lot of pilot override. Whenever you're transferring information to the aircraft, the pilot gives a check. I think one way to really fix a lot of these issues is to have more of that. Also, you add not just maintenance codes, but we maybe add hacking codes to the hub whenever we go through there. If it have certain indicators, and it would look a lot like the attack network, uh, the attack MITRE network, because we already use this anyways for maintenance problems. So why not just put those hacking codes in there? You teach a maintainer how to find these codes, and they've got it right there. And like I said, there's easy ways to fix this. We just need to push for those. And it is hard to get into these things. It's hard to test this stuff. If you wanted to hack an aircraft, you have to understand the address locations, as I mentioned. You have to have access to the gear. The gear is expensive, very expensive. And most systems have an electronic like fallback. So you lose all radios, you lose all COM bus. I'll give you, for instance, the aircraft goes to a 28 volts DC. There is a physical line between the pilot's hand mic and the COM1 radio. So there are backups, and the aircraft is designed for safety, even if something bad happens. And yeah, that's about it. If there's any questions, I'd love to take them.
Okay, well, I have a question. So are there resources available beyond just this one slide related to this?
All right, so this is a full talk. It's a full hour long, and it's available on my GitHub, and it's the same name that's here. It's the Box Swapper. So if you type Box Swapper in GitHub, you'll see this talk. And at the back, I made sure to update and keep all the links up to date. The information is out there because this stuff is standardized. You know, a company can't make devices to install an aircraft unless it's just standard. And a lot of these standards are available for public preview, to look at. So you can learn a lot of this stuff.
Looks like we have a question in the chat from Ryan. It says, can you say what military airframes you've worked on?
C5, C-17s, KC-135s, and B-1s.
Are aerospace communication and navigation systems resilient, would you say?
Yes, and that goes back to the fallback systems. There is a situation that I was involved in where an aircraft got struck by lightning, and it reset the main control unit for the power bus, and they lost everything. Luckily, all those backup systems were working. They had a backup hydraulic system all the way down to there's a system called a RAT. It's a ram air turbine, pops out the side of the aircraft. Air pushes that one little blade while they're moving forward, and it turns it. And in some airframes, it creates power. Other airframes, it'll actually create hydraulics, and they can build off of that. Aircraft are resilient. I mean, they're designed to stay in the air. There's a lot of very strict policy guidelines from the FAA for something to be in the air. And there's a lot of good fallbacks. And that's when I put this together, I wanted to reiterate that to people. It's like there's a lot of fallbacks to help things out. There's a lot of double checks and triple checks in a lot of the systems. When you have multiple inputs, say for navigation, you've got all sorts of things telling what the accurate location is, and they do parity checks against each other.
Okay, we have another question here in the chat from Ted. It says, redundancy is critical in the air. With hardware being expensive, how would we go about training with these standards or inputting crafted packets beyond of aero aviation specific coursework?
Yep, and that's what I was saying is it's got that security through obscurity for the moment. It's on our side, and it is hard to come by these things, but as we move forward, it's getting more and more easy for virtualization. I myself have been trying to look at ways to virtualize a bus environment just to get some coded words and take a look at them. There's other ways to do it. There is software out there available for free to do that. You just have to know what you're looking for. But the first step, of course, would be learning to read bus traffic, learning what it is, learning what kind of codes are going to kick out. And that's why I have this slide. It shows you how the packets broke down.
Okay, we have a final question here from Daniel. It says, any work you can share on sending malicious or modified ARINC 429 to the end of the EFB or other LRU?
I have not messed with ARINC 429 except for running radios on the systems and replacing parts after someone else had troubleshot them. And it's because I'm not a licensed mechanic. I was just assisting a licensed mechanic. And it's possible, it's doable. It's just a matter of getting it to the EFB. And as he was saying with the operating systems on those, if you know your target and you know how to get information to that target, I think it's very highly likely to put some bad information on there.
Well, thank you so much for your time today, Nicholas.
Thank you.
And we will be transitioning now to our final speaker here, which is Gabe Mounts, who will be presenting on AFWERX Space Prime.
Hey, thanks, Liz. So now for something completely different. I'm with the Department of the Air Force. So following Nicholas, I appreciate that technical discussion about aircraft. I'm going to talk about some space stuff right now. I represent the AFWERX office of the Department of the Air Force, which is a innovation office really geared toward helping the Air Force and now the Space Force better connect to the industry base, mainly the startup sector, and how we can't adopt or adapt what we're seeing in innovation within that sector for military utility. A quick shout out, I want to thank the Aerospace Village, and I want to thank my colleagues at the Air Force Research Lab running a program on behalf of the Space Force and the Air Force called Hackasat. You'll see that coming to a galaxy near you. Go to hackasat.com if you want to understand how you can hack a sat. But they gave me the opportunity to talk about this Space Prime effort. So the Space Prime initiative is one of the major lines of effort that will be under AFWERX, and in fact will be under a new office spinning out here this summer called SpaceWorks. The Prime initiative follows the successful pilot program that the Secretary of the Air Force level ran through through AFWERX, in which satellites basically, or I'm sorry, the original program was called Agility Prime, and it was all about priming the pump on a market that has that's nascent in nature, but might have implications for national security if that market were to become robust. Under the Agility Prime program, they were mainly focused on flying cars. And so what we're going to do with Space Prime will be the next Prime initiative out of the chute. And that Prime initiative is looking at how do we prime a nascent space market towards national security. In our terms, what we mean by prime the pump, we mean either accelerating a market that's a little bit nascent, embryonic, not quite mature yet, or perhaps even unlocking a market that perhaps doesn't quite exist yet through this particular effort. So this is an opportunity if you're out in the industry base on the technical side, looking at what you might help us with when it comes to the Department of the Air Force and our satellite systems in particular. I show you a schedule on this chart that just means to say that we've done a lot of due diligence on our government side to understand both what do we need from an Air Force, Space Force perspective, and then what is the market actually doing. We're to a point now that we plan to launch the Prime initiative more formally and publicly this summer, in which we are inviting teams, and those teams could be performers of any type, startup companies, teams of startup companies, big, larger companies that are maybe not already geared towards the military industrial base, and even those that are. And in fact, we also are looking to see if teams might involve academic partners and others, whereby we will select a number of performers to then take forward into this Prime effort. The Prime effort itself will have some funding behind it. It'll have a number of different funding sources potentially that can be brought to bear, given to teams to help them produce something for this nascent market to show how we might push it forward. And I'll go into some of the technical areas in just a bit. Primarily, the central part of that program will be wrapped around the Air Force's small business innovative research contracting opportunities. And there may be other ways in which we will be able to provide funding to teams to demonstrate some capability on orbit in the future. Around 2024 is what we're looking at. But we're also looking at a number of other efforts on the regulation and policy side as well to help potentially unlock a market. For the technical side, though, realizing that this is a technical audience, we're looking at a number of capability focus areas. And this is where potentially some of the technical capability that we are interested in from a Space Force, Air Force perspective comes into play. You see a number of those areas there in the chart. But for this audience, I think the most important is that we're looking at, in particular, a focus area around hybrid data processing and movement. The tagline for this particular effort is on-demand data, anytime, any place, anywhere, enabling our end users in the Space Force, the Air Force, and across the military to utilize data from space. Right in lockstep with that as well is the cyber aspect of what we'll need to embed and bake into capability if we're going to have that kind of data movement in the space sector, especially as it traverses in the space sector and traverses then into the terrestrial sector for any of the end use of that data that we might want to employ. We're looking at a bunch of other focus areas as well. One of the other ones of considerable interest is something that is coalescing around sustainability in space, having to do with what we want to accomplish in debris mitigation, remediation, and definitely the data transport issue, which enables identification of debris, is important to that as well. But a number of efforts that we will be launching underneath the Space Prime that will have one of these focus areas, if not several, maybe grouped together as an offering for industry players to chew on and bite off on. A pretty simple program, so I'm pretty much done and willing to take questions.
In the meantime, I have a quick question for you, Gabe. What actually is AFWERX?
Cool. I was going to complete the thought on what AFWERX is, an innovation office here that the Department of Air Force stood up to help us connect to the private sector and make it easier for the private sector to work with the federal government. And we'll bake that kind of process into the new SpaceWorks, where this effort, Space Prime, is going to be one of the major lines of effort. I see a chat there about more specificity with data movement. Yeah, we're looking at whatever, we know that the market, and by the way, my name is spelled wrong, I apologize, maybe I can change that while I'm talking, but the market for data movement is growing, as I think most people know, with the likes of SpaceX and others launching kind of constellation of satellites to move data around. We expect that to grow, and we're just looking at understanding what else could be brought to bear to enable that for, Space Force, Air Force purposes, including how the new constellations of satellites might inject artificial intelligence, machine learning to help drive data, especially to do a lot of the data processing, increasing data processing bandwidth on board the assets in space, which will be required to move kind of the high bandwidth levels of data around that we plan to see and are already starting to see in space. So that every aspect of the compute chain, in our opinion, would be part of that focus area, including fusion, data fusion, and analytics. Quick note: if you want to learn more about this program, Space Prime in particular, or the Prime initiative as a whole underneath AFWERX, one way is just to contact me directly on LinkedIn is probably the best place for me, or through my Twitter. Twitter is just at Gabe Mounts. Gabe Mounts on LinkedIn, and you can easily connect with me, and I can maybe point you to some more resources. I didn't mention the other focus area as we were running out of time. We're looking at, like I said, on orbit data processing and movement. We're looking at potentially how to contend with debris. One of the other elements is just advancing capability in space for things like on-orbit maneuvering, advanced maneuvering, on-orbit servicing. So this gets into actually what can we do with assets in space to eventually drive a market that might have to do with in-space manufacturing maybe even taking old assets and creating new things out of them. Something also on the table as we look at focus areas for this Space Prime initiative.
Well, I'd say if we don't have any more questions here, we're close enough to the end here that we can call this a close, I would say. I would want to thank you here, Gabe, Ken, Nicholas, and as well behind the slide deck here, Nancy, for bringing this session together and making it happen today. And also everyone in the crowd who actually showed up to participate. So I hope you have the rest of your conference week and you enjoy it thoroughly. Thanks so much.